So hello guys, welcome. So we're finished with our tissue processing and we are now on staining. So our tissue sections are on the slide now and we will just stain it. So ando na tayo. So guys, we'll talk about today our routine stain, the most common stain that we use in histopathology section, which is your H&E, Hematoxylin, and Eosin. So could I just show you a sample tissue of a slide stained with H&E? So this is a uterus. So uterus, it's filled with smooth muscles. So smooth muscles, guys, when stained with H&E, gives a pink, deep pink color. Yan, mas bright, mas vivid yung pink. Pag smooth muscle yung ini-stain niya. At yung mga dark colors natin dyan na circles, those are nucleus. So in H&E staining, mga blue-black ang result ng nucleus. Okay, here, these are columnar epithelial cells. Yan. So your nucleus looks like blue-black, blue-purple color. The cytoplasms of the epithelia, columnar epithelia, guys, are light purple. And itong border na to, kung saan may arrow, these are your microvilli. So, ang ganda ng stain na to, guys, kasi the microvilli are very evident. So, yan ang pag-usapan natin today. So, let's brace ourselves. Let's brace ourselves. So what is the reason for staining? Why does a tissue stain? What are the staining mechanisms, types and methods of staining, different types of dyes, and H&E staining? So for the special stains, guys, it needs another PowerPoint. So why does your tissue stain, or how come we could stain our tissues? Okay, so your tissues, guys, has different affinities when it comes to stain. It could attract different types of stain based on its chemistry, based on antigen-antibody reaction, interaction. So merong different factors why a tissue could stain. Okay, so when we are staining, we are applying dyes, either natural dyes or synthetic dyes, so that we could differentiate, we could decipher the different structural components, the architectural pattern of your tissue, so that we could decipher, we could distinguish which is the nucleus, which is the cytoplasm, which is the whole tissue, which is the background. So stains are used. So example, guys, your tissue and cells has different affinities. So some are acidic structures. So acidic structures, example, nucleic acids, your DNA, your RNA, they have greater affinity to basic dyes. Kaya they turn blue or dark blue or blue-black. And your basic structures, just like your cytoplasm, your mitochondria, your Golgi body, they have greater affinity for acidic dyes, for red dyes. Yan. Kaya medyo may pagka-purple yung mga cytoplasm. Light purple, light pink. So, what cells are this, guys? So, review sa hematology. Kasi nga, hematology to kasi yung paligid niya, red blood cells. So, this is so very prominent yung mga granules niya. Mataas siya pag may mga parasitic infection. So this one has an affinity for acidic dyes, for eosin. Kaya eosinophil ang tawag sa kanya. And this dude right here, basophil. Ayan. So it's basophilic. Yan, it attracts your basic dyes. That's why it's blue in color and very evident yung granules niya. Yan. So very rare makanap ng basophil sa smear. So these are a few reasons why a dye could attach to your tissue. So first is covalent bonding. So these are intermolecular. So these are bond between molecules, between two molecules yan, especially if they are two non-metal atoms. So example, Fulgen stain, PAS, periodic acid shift, and mercury orange for thiols. So covalent bonding, ano pa, solvent-solvent interaction. Ay, dito muna tayo. Dito muna tayo sa electrostatic or Coulombic affinities or electrostatic attraction. So basically guys, unlike ions, so opposite or different ions attract each other. So example, ito, basic dyes, they attract, yung basic dyes are positive ions or cation. So they attract DNA, which are negative ions, mga anion, yung mga nucleic acids. Okay, acid dyes, mga anion sila, negative charge. So yung mga ina-attract nila mitochondria. So they are opposite in charge. Okay. Next, hydrogen bonding. So when there are two hydrogens, there are interaction between them. Ito, intramolecular interaction. So if there are two hydrogens present. So example, in carmine. So mamaya, pag-usapan natin yung carmine from cochineal dyes. Congo Red, van der Waals forces, yan. Ito, pag nagbasa kayo ng Bancroft, guys. So, van der Waals forces are important intermolecular forces. Ito, intramolecular forces among large molecules. So, when there are two large molecules, they have an interaction with each other. Sabi nga, dipole-dipole interaction. So, example are there direct dyes, yung hindi kailangan ng mordant. Alum hematoxylin, kailangan ng mordant, and elastic fiber stains. We also have covalent bonding, yon, two non-metals. Solvent-solvent interaction. So, guys, when there is water, so when there is aqueous solutions, they have an interaction with each other. Staining systems using aqueous solutions of dyes. Yan. So, when there is water, yan, one could dissolve on that solvent, ganyan. Example, alkaline phosphatases, leucoesterases, mga enzyme, substrates. We have stain or dye or reagent interaction, the attraction. So, they tend to aggregate with one another. So, metachromatic staining, inorganic pigments in Gomori type enzyme histochemistry, and so on. So just to give you an overview on how your tissue is attracted, your dyes are attracted to the tissue. And we have physical staining. Yan. Simple solubility. So guys, your fat stains yan, are soluble in fat. Yan. So example of fat stain are Sudan dyes. And aside from that, we have absorption. Yan. The ability to absorb or attract a dye. So types and methods of staining. So guys, we have three. So the most common stain in the laboratory in histopath is histological staining. So when there is a direct interaction with the tissue and the dye. Okay, so histological staining. Example, yung H&E staining natin. Okay, bacterial stains, your gram staining. Next is your histochemistry. So your staining happens because there is a chemical reaction between the tissue and the reagent. Okay, there's a chemical reaction. So example, your pearl's Prussian blue, okay, becomes blue if it reacts with iron. Your periodic shift becomes red when it reacts with glycoproteins, okay, with carbohydrates, okay. So enzyme histochemistry happens when your substrate is converted to a product, yan, through the action of an enzyme. So next is immunohistochemical staining. Okay, so so there is an interaction with antigen and antibody staining. So with antigen-antibody interaction. So guys, we use the principle of antigen-antibody reaction and apply it on identifying tumor markers, mga tumors, mga proteins, guys. So we utilize antigens and antibodies. So we utilize monoclonal and polyclonal antibodies, fluorescent labeled antigens or antibodies, and enzyme labeled antibodies. So here guys, yan so yung pinaka-memorize ko kasi ng paggamit ng periodic shift guys is pag may leukemia. Okay? So periodic shift positive happens in cases of acute lymphocytic leukemia and subtype M6 of acute myeloid leukemia. So guys, your different subtypes of leukemia, guys, yung iba, most of them are periodic shift negative. Pero M6 lang ang periodic shift positive. Okay? Next, guys, kung may siderotic granules, so siderotic granules are the formation of iron. Yan. So there is something wrong with the heme production. Yung iron nag-accumulate sa cell natin, siderotic granules. So these cells are called sideroblasts. So sidero, yan, it points to iron. Yan, may iron siya. So nagiging blue ito pag sinestain ng Prussian blue because it reacts with the iron of the sideroblasts. So we have different types of methods of staining. Meron tayong 8, direct and indirect, progressive and regressive, and metachromatic staining, counterstaining, metallic impregnation, wag malilito, biglang may impregnation dito, and vital staining. So direct stain, so it does not require a mordant. Yeah, no mordant required. And indirect staining, guys, it needs a mordant. Okay? Kailangan ng mordant to use it. So, what is mordant, mamaya? So, example of mordant here for gram staining. So, huwag kakalimutan yung gram staining, di ba? So, VIAS, crystal violet, iodine, alcohol, and safranin. So, ang nang mordant dito, iodine. Yan. So, your mordant, guys, creates a bridge. Yan, creates a bridge between your dye and your tissue. Yan, it creates a bridge, a link. So it improves the staining. Yan. So and sa indirect staining, it also uses accentuator. So dito ang mordant natin, iodine. Ang decolorizer natin, alcohol wash. Yan. Counterstain, safranin. Ang primary stain natin, purple or crystal violet. So just take note so may mga word tayo na decolorization and counterstain. Okay? So kung usually yon meron tayong primary staining and the counterstain. Okay, ang counterstain. So yun ang mga pag-aaralan nating terminologies today. So mordant creates a link or a bridge between the tissue and the dye. So for hematoxylin, yung H and E natin, one of the most common mordants that we use is potassium alum and ammonium alum. So usually potassium alum. Yan, we also have accentuators, yan, hastens, yan, increase the rate of the dye, increase the rate of staining and intensity of the dye, and also the selectivity of the dye. So, accentuator ang phenol. Yan. Ang raming use ng phenol, guys, so far sa study natin sa histopath, diba? 1% phenol could be used as tissue softener. Yan. 1% phenol also is a fungicide. Saan na ba yun? Sa gelatin. embedding media. So marami. At it could be an accentuator in carbon fusion. Also, we have a differentiation or decolorization. So differentiation and decolorization uses differentiating agents or decolorizers. Okay, so they are the one which partially or completely remove the excess stain. Okay? So, sometimes there is overstaining, guys, at para mabawasan or to completely remove yung stain, we could use water, acid alcohol, dilute acid, and alcohol. Yan. So, usually acid alcohol. Yan. Sa gram stain, alcohol ang ginamit. Pwede ring acid alcohol. So, weak lang tong mga to, ha? So we have mordant. So it links the tissue and the dye accentuator, hastens the speed of staining, intensifies it, increase the selectivity. So differentiation or decolorization. So it partially removes the stain. So we have two rin. We have progressive and regressive. Yan. So when we say progressive, class, one step at a time, it is slow and selective. Yan. You place a stain at a specific time and specific sequence. So pakunti-kunti, yan, pakunti-kunti mo ini-stain. Hence, your hematoxylin should be less concentrated to prevent overstaining, and decolorizers are unnecessary. Kasi nga, pakunti-kunti ka lang nagsistain eh. One step at a time. It is slower and selective. Yan. You progress. Okay? You move forward, pakunti-kunti lang. Here we have regressive staining. So regressive staining, guys, tends to be faster and more convenient because you overstain the tissue. Okay? Simula pa lang, lunurin mo na ng stain. Okay? Then partially decolorize. Okay? So there is a need of decolorization for regressive staining. So paatras naman to. Okay? Kasi na-overstain mo in the first place, so you will decolorize it. So parang gram staining, you need a decolorizer. Okay? So regressive needs a decolorizer. It's necessary. For progressive, it's unnecessary. Okay? And your hematoxylin must be more concentrated because your goal is to overstain it nga eh. So it rapidly diffuses and it's more convenient. This is faster. So your hematoxylin and eosin are usually regressive staining. Yan. Yung routine natin na ginagamit, ha? Regressive staining siya. So next, we have metachromatic staining. So guys, metachromatic staining, sa may example ko, ito. So toluidine blue is blue. Okay? But once it comes in contact with your muscle, it turns to pink or purple. Pink to purple. So guys, this happens. So some dyes, yan, will change into different color once it comes into contact with a metachromatic tissue. So example, muscle. Class, hindi lahat ng tissue undergoes metachromasia. Mast cell, amyloid, yan. Highly sulfated substances, yan thing, tissues with high heparin content, yung mga mucopolysaccharides, yan, amyloid, mast cell granules, yan. Those are the tissues which produces metachromasia and will produce metachromatic staining. Okay? So, ang toluidine blue is blue. However, once it contacts to it comes into contact with muscle, it turns into pink. Okay? This happens due to polymerization. Your mast cell granules are highly sulfated. Okay? So, nag-iiba yung kulay once it comes in contact to some tissues, certain types of tissues. So mast cell granules, amyloid, mucopolysaccharides, they have high heparin content. However, nasa na yun? Yan. Example of metachromasia of stains, yan, methyl violet, methylene blue, thionin, and toluidine for frozen section, and crystal violet. Yan. So amyloid, mucin, ano to? Mucin substances, yun nga, may mga mucopolysaccharides. So which of the following, what are the factors that enhances your metachromasia? Increasing in the dye concentration, decrease in temperature, cold temperature, the pH, and water. Yan. So it improves the van der Waals forces. So the opposite, guys, of metachromatic stain is orthochromatic stain. Sabi niya, property of dye or stain do not change on binding to a target. So the stain does not change in color upon the binding to a target. So opposite. So metachromatic staining, so the stain change in color once it contacts with a target. For orthochromatic stain, guys, it does not change in color. Cartilage ata to. Not sure, guys. Sorry. Okay, next is metallic impregnation. So, class, yan, wag malilito sa word na impregnation. But sabi nila, metallic impregnation is not a type of staining. Yan. It's a way of putting color on your tissue. However, not by stains, but by metallic salts. Yan. So the common metallic salt that we use is silver. Yan. Silver, gold rin ginagamit, pero not that common eh. So here, I'm going to discuss two types of silver that could be impregnated, that could give a color to your tissues. Yan. We have ammoniacal silver. Yan. For melanin, for argentafin cells that contains melanin, for melanin intestinal glands, reticulin fiber, ginagamit ammoniacal silver. And methanomen silver for staining or adding color to your basement membrane and fungal hyphae. Yan. So itong ginamit dito, ammoniacal silver, because it's a reticulin fiber. So metallic salts, yung nagbigay ng dark color dun sa reticulin fiber. So reticulin fiber, guys, are a network of fiber. They are your connective tissues, diba? And here, so metallic impregnation na rin. However, they use methanamine silver. So they added color to the basement membrane. Yan, kumbaga parang drop-down shadow. Yan, so shadow sa basement membrane. At ito, yung mga dark color na hyphae ng fungi. Next is vital staining. So vital staining, guys, has the capability of penetrating the living cells without killing it. Okay? Therefore, guys, vital staining do not reach the nucleus, ha? Because kung na-reach na yung nucleus, nalagyan ng stain yung nucleus, mamamatay yung cell. Okay? So it is capable of penetrating the living cells, yan, to assess the functional activity and cell physiology. So we have two types, supravital staining. So first F is your supravital staining. So it could stain the living cells that are already removed from the body. So ang pinaka-common na nilalagyan natin ng supravital stain in hematology are your reticulocyte. Yan, itong mga reticulocyte. So these are reticulin fibers. So these were stained with brilliant crescent blue and or methylene blue pag reticulocyte ang ini-stain. And we also have Heinz bodies. Yan, Heinz bodies. So what are Heinz bodies? Yan. So anong nag-precipitate in Heinz bodies? So you could also stain it with your supravital staining. So natanggal na yung cells outside the body. And the best vital dye daw is neutral red, and for vital staining for mitochondria is Janus green. And we also have intravital staining. So when we say intravital, so the cells are still living because it's still attached to the body. So example of vital staining is this one. Here, they use 1% toluidine blue. So we have a lesion here. Tapos nilagyan ng 1% toluidine blue. Yan. So these are used by doctors, by pathologists to assess, to screen malignant lesions in the oral cavity. Here naman, guys, so this is without staining it. And here, they added Lugol's iodine. Yan. So, apparently, here, guys, yung white part, yan, it was not stained with Lugol's iodine yan. For screening suspicious lesions in the buccal mucosa. Yan, galing. So let's talk about your natural and synthetic dyes. So we have two types. So here, natural dyes, so they came from natural sources: Hematoxylin, Cochineal, and Eosin. And we have synthetic dyes. Yan. Pag-aralan natin saan sila galing. Yan. So interesting to. Okay. So for Hematoxylin, so guys, it's from Central America. Yan. So yan, ang raming punong pinuputol, or they really have a production for this. Yan. Ang galing, no, guys, galing sa puno yung hematoxylin. So however, guys, hematoxylin yan. So galing siya sa Hematoxylum campicianum. Yan, Hematoxylum campicianum. So yung logwood walang niya, guys. Tignan nyo naman, may kulang na. However, guys, hematoxylin daw is colorless on its own. It needs to be oxidized to hematin. Okay? And addition of more than para magkaroon talaga ng kulay. So, as a hematoxylin in itself, hindi mo pa talaga makikita yung kulay niya. You need to release the active substances. So you need to oxidize it to hematin. Okay, kailangan lang may ma-oxidize. So how would we oxidize it? And the addition of a mordant. So oxidization or ripen it. Okay, so mamaya pag-usapan natin yan. And we have also your cochineal dye. Ang galing nito, guys. So, a cactus in Central America pa rin ata to, guys. Sa cactus na yon is merong cochineal bugs, yan, or Dactylopius coccus, yan. So, these are your bugs, yan, insects. So, ayan, kinukuha nila. Ang galing nga nito, yung mass production. So, meron silang tagasalo sa mga cactus na to, where your bugs live. Yan. And once you will squeeze these bugs, guys, red yung labas niya. Galing, itong bug na to. Yan. So, yan, you will dry it and you will pulverize it, this bug. And to release that carmine color, that scarlet dye color, you have to add aluminum or calcium salt. Guys, ever since the beginning of time, ginagamit na nila to as dyes. Itong mga bugs na to. Okay? So, kung nakakita ka ng carmine stain, yan, best carmine stain, yan, galing yan sa cochineal dye or mga bug. And we have Eosin. So Eosin, guys, is a stain that is used for staining your elastic fibers. Yan. Ganda yung elastic fibers. And guys, they are extracted from lichens. Yan. So lichens daw, guys, is a cross of a fungi and an algae. So yung pamilya niya, it's between a fungi and an algae. And so yun, yung Eosin na dye galing sa lichen or orchella weeds. Yan. Tapos, baka maririnig nyo, vegetable dye. Pero totoo, hindi vegetable. Hindi naman vegetable ang lichens. Pero yung tawag nila, vegetable dye. And guys, we have synthetic dyes. Ito mas magaling na naman kung saan to galing. So guys, we have coal. So coal are turned into fuel, into gas. Yan. And its end product, one of its waste products are your coal tar. Yan. Coal tar. And once it undergoes fractional distillation, guys, it will produce the different dyes. Hindi ko alam kung paano ginawa yun, but yun. It will produce aniline bases. Yan. That could be used for dyes, for paint. Yan. Ang raming use ng coal tar. Okay? So from coal, nagagawing gas, one of its end byproduct are coal tar. And after fractional distillation, it could create aniline bases that could be used for staining, for paints, for dyes, for textile, and so on. Yan. So yan, basic dyes, acidic dyes, and neutral dyes. Example, Romanowski Gemsa. Gemsa pang blood. So let's head on to your H&E staining na tayo. So guys, what are the properties of hematoxylin? So just like what I told you a while ago, it has no hematoxylin in itself, guys. Wala siyang kulay, okay? So you need to ripen it or to oxidize it so that the active coloring substance will come out, which is your hematin. Okay, so the examples of your ripening or oxidizing agent. So example, ibababad sa sunlight 3 to 4 months. Yan, mabagal lang. Pero mas mabilis itong mga to, mga chemical oxidizers or ripening agents. We have sodium iodate, mercuric oxide, hydrogen peroxide, potassium permanganate, and sodium perborate. Okay, so para mailabas yung hematin. So hematin is not enough, okay? You need to add mordant as a link between the tissue. So ang common is ammonium or potassium alum, okay? So mordant, hematin plus mordant, it will form a hematoxylin lake or dye lake. So stain, may mordant, may tissue. We call it a lake. Yan. So, yeah. So, your hematin could be acidic or alkaline, but usually it's alkaline in pH. Hematin has the affinity for several tissues. Yan. Different shades of purple, different shades of pink. Yan, sa hematin. So, H and E tayo, diba? Hematoxylin and Eosin. So, yung H, yung nauna, that's your primary stain. And usually, that's your nuclear stain. And your Eosin is your secondary stain or your counterstain. So, ayan, review lang. So, for hematoxylin, to be converted to hematin, kailangan ng oxidation or ripening. Okay? And class, para mas mapakulay pa yung hematin, kailangan mag-add ng mordant. Okay? Para ayan, makagawa ng alum hematoxylin. So, kunyari, potassium alum, yan, alum hematoxylin. Ayun. And yan, plus, so this is your alum hematoxylin. Tapos, it can now bind to your DNA. Yan. So, because it's a nuclear stain. Yan, that's it. So we have different types of hematoxylin. So this hematoxylin can vary, guys, based on the mordant that you will use. Okay? So pag alum hematoxylin, alum ang mordant. Pag iron, iron ang mordant. Tungsten, tungstenic acid ang mordant. Copper, copper ang mordant. Okay. So lahat ng alum hematoxylin na to, alum ang mordant nila, potassium alum. So guys, once you use alum hematoxylin, the color of the nucleus still is red. Okay? Red pa siya. So nagiging blue siya. Guys, ma'am, Sabi mo yung nuclear stain, ano? Yan, magiging blue. Yan. So, magiging blue siya after a bluing agent. Okay, wag mali ito. So, usually in itself, yan, red pa talaga. So, hematoxylin plus a mordant plus red ang labas. Okay. So, here, yung Ehrlich's alum hematoxylin, so they have different ripening reagent. Okay, so take note lang. So, we have Ehrlich's, Harris, Hills, Delafields, and Mayers. Yan. Meron pang Kolf eh. So, itong Ehrlich's, guys, it's a regressive. Yan. Usually, ito yung ginagamit sa laboratory eh. Alam ko, Ehrlich's. And Harris. So, Hills, Delafields, progressive. Mayers, both progressive and regressive stain. So, yun nga, sabi ko, para maging permanent yung color ng nucleus, kailangan ng bluing step after using alum hematoxylin. Yan. So, we convert the initial soluble red color to blue color, okay? Because this blue color is more permanent, okay? So, how does bluing step happen? So, we add an alkaline pH substance, okay? So, for the lake, more than dilake to form, para mag-form yung dilake, kailangan ng bluing solutions. So, these are alkaline, slightly alkaline in pH. So, guys, para yung nucleus natin maging blue, kailangan check natin yung alkalinity ng bluing step natin. So, bluing solutions are ammonia water, dilute lithium carbonate, or Scott stop water, which contains potassium carbonate, magnesium sulfate, and water. Okay, so after doing aluminum hematoxylin, we have a bluing step. So, pag nakita mo na yung ammonia water or Scott stop water, the purpose of that is the bluing step. Yan. Yan. Naglilito ako sa spelling. Some spells bluing like this. Some spell it like this. Ganito na lang, guys. Bluing step. So, after using alum hematoxylin, okay? So, next. So, for iron hematoxylin, the mordant is iron, okay? But we have two types of iron. We have ferric chloride and ferric ammonium sulfate. So, if the mordant is ferric chloride, we call it Weigert's. For ferric ammonium sulfate, we call it Heidenhain's. So, your Weigert's are for muscles and connective tissue fibers. So, if it's your Weigert's is added with Van Gieson stain, it's good for collagen and entamoeba histolytica. We have Heidenhain's for mitochondria, muscle striations, and myelin. Okay, so we have two under iron hematoxylin, Weigert's and Heidenhain's. So iba yung Heidenhain's susa. So next is tungsten. So hematoxylin, so phosphotungstic acid. So ang ripening agent siya, either sunlight or potassium permanganate. So it's good, guys, for muscle striations. Yan. Ito, skeletal muscle to. Yan. So pag narinig mo yung Mallory's phosphotungstic acid hematoxylin, that's tungsten hematoxylin. Okay, when we have copper hematoxylin for spermatogenesis, for exhibiting the development of sperm. Next, guys, is our secondary stain or counterstain or yung cytoplasmic stain natin, which is Eosin. So, partner sila ha. So, itong Eosin, yan, pag hematoxylin yung primary stain niya, it is used after. So, stain mo muna ang hematoxylin tapos counterstain Eosin. However, yan, so counterstain is counterstain, it's performed before methylene. If methylene blue naman yung partner niya, it's before methylene blue. Okay. So your counterstain, guys, so it highlights the other, it highlights the background of the tissue, other components of the tissue. Okay. So, ayun. And it's acidic. So the most common eosin are your eosin Y, eosin B, and eosin ES. So Y means yellowish, B means bluish, ES means ethyl eosin. So may pagka-alcoholic eosin. So ikaw nang balang pumili dyan. But the most common used is eosin Y or eosin yellowish. Yan. But yun naman yung ripening agents ko. So steps on your H&E. So guys, timed itong bawat step ha. So far yung time, hindi naman masyadong mahalaga as of now. So mga 1 minute to 3 minutes usually yung time, okay? Ang mahalaga is the rationale behind those steps. So class, here we have 12 steps in all, okay? So medyo marami, but it's only short, okay? Short lang yung time per tissue coupling jar or tissue rack. So first is silene, okay? So first is silene and we have 2 changes. So the purpose of this is for the paraffinization or dewaxing to remove the paraffin wax, okay? So una, mahalaga is tanggalin yung paraffin wax sa tissue section natin. So nakat na tissue section. Why? Because paraffin cannot be stained. Okay? Cannot be stained. So it must be removed. Okay? So pag meron pang paraffin wax na natitira guys sa tissue natin, hindi yun masistain. Okay? Or may patches of paraffin. So we could remove the paraffin through 2 changes of silene. Okay? And next, guys, is descending grade of alcohol. So every time we use a descending grade of alcohol is for rehydration naman, okay? Yung opposite ng dehydration, ascending grade of alcohol. So here, so mataas na grade tapos pababa na grade of alcohol, descending grade of alcohol is for rehydration. So here now, you're preparing the tissue section, yung nakat na tissue, guys, to absorb water. Okay? So you are preparing it to absorb water. Kasi yung mga stain natin, guys, may tubig siya. So that it could retain the stain, you should prepare your tissue for water. Okay? So dapat ma-hydrate. You return back the water by rehydrating it. Okay? And wash it with water. So, this purpose yan is for the removal of pigments, kung may naiwang pigments from the tissue processing, from alcohol, from silene, yan, to remove the pigments. Next is your alum hematoxylin. Yan. So, ito yung mga regressive na stain. So, this is your primary stain, di ba? Ang mordant dito, potassium, alum. Sorry. Yan. So, the result, class, is red-purple, di ba? Red pa yung nucleus. So, kailangan ng bluing step. Mamaya may bluing step. Then, rinse in tap water. So, guys, sometimes, yan, dito nagkaka-errors eh. When there is inconsistency with how you rinse the tissue, how you agitate the tissue, pag manual staining, yan, discrepancy sa stain when it comes to rinsing. So, dapat maging standardized to. And next is acid alcohol. So, acid alcohol is a decolorizer or a differentiator. Okay? So, it removes the excess hematoxylin. Okay? It removes, so if there was overstaining, it will remove the excess differentiator. So, it's a differentiator. So, guys, there is here, yan, may water, yan, so that the alcohol will not contaminate your hematoxylin. Okay? So, class, as time goes by, pwedeng ma-dilute tong hematoxylin mo kasi nga nalagyan mo ng water, yan, kung hindi mo tinap off yung water, or pwedeng malagyan ng alcohol. Okay, so yun lang, check. So ito, nirinse mo naman tap water, so pwede mo ma-dilute itong acid alcohol because of the excess water from the rinsing. So you have to just watch out to completely tap off the water or remove the water. Okay, kundi nadadilute mo yung mga reagent mo. We have ammonia water or either 1% lithium carbonate or Scotch tap water. So now this is your bluing step. Okay, now we are turning your nucleus from red to a more permanent, which is blue, blue-black, or dark purple. Yeah. Then, so itong bluing solution mo, it's also water or pH sensitive. Yan. So kung nadadilute mo yan, kailangan mo nang palitan. Next, wash in tap water, then stain with your Counterstain, okay, which is Eosin Y. Then now, you will dehydrate. So, dehydrate is the removal of water na, okay? So, removal of the excess eosin, removal of the water. Now, we will use ascending grade of alcohol, okay? Then, silane na tayo, clearing to make to improve the optical clarity, to make the tissue transparent so that light could pass through it upon microscopic examination and mounting and labeling. So here guys, we use a cover slip and a mountant. Yan, to store, yan, to immortalize our tissue slide. Yan, mounting and labeling. So class, kailangan matanggal yung tubig yan para walang droplets sa final end product natin. Okay, yung water droplets. So expected staining result. So guys, the nucleus should turn blue or blue-black. Yan, mga nucleus. Cytoplasm, pale pink. Ito, pag calcified bone, purplish blue daw. Pag decalcified bone, pink. Muscle fibers, deep pink. Yan, parang yung uterus ng first slide. And so on. So this is H&E staining. So yan, this is just an overview of your procedure. So yung deparaffinization, tapos descending grades of alcohol, tapos wash, tapos hematoxylin, tap water, tapos walang bluing reagent. Yun lang, walang bluing solution. And next is Eosin. Tapos ascending grades of alcohol for dehydration. Tapos clearing na naman, silane. Then we will not allow it to dry out, okay? So lagyan mo na ng mounting media, lagyan mo na ng cover slip, and allow it to harden. Tapos pag natuyo na, it's ready for light microscopy. So finally guys, ito, quality control in H&E. So I just want to show you yung mga kailangan bantayan, okay? So since hindi pa natin alam, hindi pa tayo nag face to face guys, at least, 'di ba? Kailangan yung bantayan tong mga to. So example, same tissue manually stained by two different people. So class, it's very important na bawat station, there is accurate timing. So, magkaiba daw yung nag-stain dito manually. So, accurate daw dapat yung timing per stain. So, pag nagmamadali na, yan, standardize the staining condition, the agitation, the washing, and the draining. Dapat, consistent tong mga to. At mangyayari tong mga to, guys, kung automated yung stainer. Okay? And guys, ito, mahalaga to. Use control slides to monitor the stain. Okay? So, example, meron ng mga slides na nakastore sa laboratory. And every day or sabihin natin 3 days, you are checking kung yung quality ng H&E stain nyo. Kasi guys, you could reuse these stains, your reagents, okay? However, you have to replace it if nagiging light na yung stain, hindi na maganda yung quality ng results, okay? So as a good quality measure, kailangan may control slides ka. Okay. So next, guys, ensure the complete removal of residual wax. Yan. Because here, yan, may mga blank spaces. Because in these blank spaces, yan, dito, so may mga excess paraffin pa. Yan. These areas are unstained because of the residual wax. Next, solvents and staining reagents are regularly replaced. Yan, based on the number of slides stained or wax process. Yan, depending on the suggestion of the manufacturer, kung ilan yung pwede mong gamitin na slides before you have to replace it already. Okay? And sometimes you could check it using your control slides. And slides are thoroughly hydrated prior to hematoxylin. Yan. So, prepare it properly. So, kailangan you have exposed it to xylene and descending grade of alcohol. Yan. So, be careful lang because your alcohol and xylene can contaminate your stains. So, you have to drain it properly. At kung automated naman, walang problema. So here guys, anong mas maganda yung nuclear staining niya? So A ba or letter B? Ano yung nagsho-show ng more detailed staining? Hindi ba yung letter B? Yan. So detailed nuclear staining happens when there is complete bluing. Okay? So solutions may be contaminated with tap water and could destabilize the pH or change the pH. Yan. So dapat weak alkaline. Okay? So baka nagiging neutral na yung bluing solution mo, kailangan mo nang palitan. Yan. So ayun. Bluing is followed by a very thorough wash in tap water to remove residual alkali that could impede the eosin staining and cause weak and uneven staining. So guys, ang eosin, if I'm not mistaken, is acidic, okay? So pag nilagyan mo siya ng bluing solution, it could impede your eosin. So one solution of that daw is add acetic acid. The performance of hematoxylin solution should be monitored. So guys, this is 7 days apart. So ito kunyari nung Monday, yan, next Monday, ito yung itsura. So ikaw ba, 'di ba? So mas maganda ito. So might as well replace your hematoxylin reagents already because there are carryover and dilution. Yun nga eh. So, pag hindi maayos yung draining. So, might as well replace your hematoxylin solutions. Okay? So, the pH of eosin is monitored. It should be at 5. Yan. So, dahil nakakontaminate ng bluing solution, nagiging alkaline. So, add daw a few drops of acetic acid. So, sections are thoroughly dehydrated and cleared to remove the water droplets para hindi siya makita sa under the microscope. Okay? So, the cover slip is always applied before the section has a chance to dry. So, we don't allow your section to dry out. Okay? So, nandoon lang siya nakababad sa xylene unless you are ready to mount it. That's the only time that you will remove it in your xylene. Okay? Ayan. Long-term storage qualities of the mountant must be known because crystals can appear in poor quality mountant. Okay, so huwag gagamit ng expired or poor quality mountant kasi it will produce crystals. Yan. So guys, just review yung mga staining rack, coupling jar, yan. Yung mga staining dishes. Yan, yung automated stainer natin. Yan, stainer to kasi nga staining dishes yung ginagamit. So, mas maliit. Yan, for staining siya ng H&E. So, especially if you are staining a huge batch of slides. Yan, maganda. At there is consistency with draining, with agitation, with washing. So that's it, guys. Thank you for listening. Bye-bye.